This is 3.5 part 2. This deals with reflections. 3.5 part 2. So this corresponds with the homework today. 3.5 part 2 homework. Okay. This deals with reflections. So we're going to talk today about two kinds of reflections. One reflection is a vertical reflection. If you're looking at this picture up here, the original function is going to be the blue one. That's f of x. The teal one, located here, is the vertical reflection. It's what happens if you fold that blue function over the x-axis. Okay? How do we get there? How do we get that reflection? Typically, we multiply f of x by a negative number. Okay? So pretend like this was the square root function. And let's let this be f of x equals x squared. How do I come up with this reflection down here?
Negative x squared.
Yeah, f of x equals negative x squared. Okay, y'all should have learned that in Algebra 2. So when we see that vertical, or in Algebra 1, when we see that vertical reflection, that's a reflection over the x-axis. Typically, it's just a negative multiplier on that function. Okay? The other kind of reflection, and we won't spend very long talking about, is horizontal reflections. Horizontal reflections. That's a reflection over the y-axis. What happens here is all of your x values are negative. So what I have possibly at, let's let this be x equals 4. Then I'm going to reflect that, and I should have the same y value at x equals negative 4. See how that's working? So as it goes across that y-axis, I should see a mirror on both sides. Yeah? Okay. If you're going to write anything down from this function, you should write down here. Couple of notes on reflections. There's two things that you probably want to be interested in. If a new function g of x equals negative f of x is a vertical reflection. A new function g of x equals f of negative x is a horizontal reflection. Notice where that negative sign is. If the negative is in with x, it's horizontal. If the negative is outside, it's vertical. That holds true with yesterday. The inside stuff deals with x, it's horizontal. And the outside stuff deals with y. And that would be vertical. Say it again. Oh. All right, so this is example 9. I know that we've just started this lesson and it feels like, how are we already at example 9? Remember that we're in parts of a bigger lesson. Okay. So example 9, it says reflect the graph of s of t equals square root t vertically and horizontally. Okay. Not too bad, yeah? So the first thing I would do if I were you is I would envision s of t equals the square root of t. What does that look like? The square root function, it goes through 0, 0. We could make a table. For s of t, we know that if I input 0, I output what? 0, right? I'm taking the square roots here. If I input 1, I should output what? 1. What's the square root of 1 is 1. What's the square root of 2? No, it's decimally. Skip to 4. 4 is the next perfect square. So if I input 4, I output 2. We should be able to plot that particular function. 1, 1, and 4, 2. Do y'all recognize this as s of t? As a square root function? Okay. Now, it wants us to reflect this thing vertically and horizontally. So let's go vertical first. To get a vertical function, this is going to be negative s of t. And what it says up here is I multiply all of the outputs by -1. So all of the outputs from S of t are going to now be negative. Well, what's -0? 0. But I can reflect 1 by plotting that point at -1, right? And 4 comma what? -2. If you plot those new points, you'll see that this is a direct reflection over the x-axis. This is a vertical reflection. How do you reflect it over the y-axis? So that's right here. Multiply all the inputs by -1. Multiply all of the inputs by -1. So S of -t is going to be a very similar function, but now we're going to have all of our inputs multiplied by -1. And our inputs are 0, so I'm still going to have 0, 0. This thing has not translated off of the origin. What's my input going to be now? So I'm going to have a dot at -1, 1. And my input, -4, output 2. Okay, so if I plot those points, I've got an ordered pair at 0, 0, -1, 1, and -4, 2. And now he's reflected across the y-axis. Okay, I'm trying to keep it where you guys can see that, but I don't know that I'm doing a great job. Is that okay? I'm just changing the inputs and outputs. I'm not worried about how did I get there, square rooting negatives or not. It's a good idea, though. We're just basically reflecting the plotted function. All right, let's go on to the next page. Are y'all okay here? Wyatt, is that a confident thumbs up? I said, is it a confident thumbs up? Okay. All right, next we're going to reflect a table of values. I got to give you the table, though, so be patient with me. This is example 10. Reflect a table of values. Okay, so we have x and f of x. So our input and output, we've got 2, 1, 4, 3, 6, 7, and 8, 11. So you're going to draw a graph over here, but on your graph, you probably want more room in x and y than you have in negative x and negative y, because it feels like these are pretty positive points. So 2, 1, 4, 3, 6, 7, and 8, 11. You have something that looks like this? The first kind of reflection it wants is over the x-axis. So we're going negative f of x, which means I'm going to keep my input. Input's going to be the same, but the output's going to be negative. which is pretty similar. The last thing, it wants to reflect across the y-axis. So now you'll have f of negative x, which is to say I'm going to change all of the inputs to be opposite signs. So negative 2, 1, negative 4, 3, negative 6, 7, negative 8, 11. And I'm going to run out of room on mine. I can tell you right now.
I already did.
I think you get the idea, though.
Yeah, we'll just call it.
We'll just call it. Okay.
Point made.
Point made. Do we understand? Questions here at all? How reflecting x-axis, y-axis? Life is good.
Is this what our homework is?
Meh.
Oh,
We're getting to the place of the homework.
this isn't it.
No, not quite. All right, let's go on to a function. Okay, I've had enough of the points and table business. Let's do a function. This is example 11, they said with cheerfulness. Example 11. Given the toolkit function f of x equals x squared. Graph with it starts with an F. What?
So we're getting away from that.
Away from the table. Graph g of x equals negative f of x. And h of x equals f of negative x.
So vertically and horizontally.
Yeah, so we're going to flip it vertically and horizontally, but we're going to start out with our function f of x equals x squared. Give me some good points for that.
0.
0, 0. What else? 1, 1. What else?
2, 4.
Do you notice that that was exactly opposite of the square root function?
Yeah.
We had 0, 0, 1, 1, and 4, 2. This one goes 0, 0, 1, 1, 2, 4. Fun fact.
9, 3.
Yeah, 9, 3. I think let's just go to 2. And we go to the same points on the other side. That was
good.
Okay, so for G, let's switch colors here. Let's do it in pink. I need a pinkin.
Wait, why do you already do the same side? Wouldn't that be vertical?
So this is the parabola. This is the whole thing. This is all of F.
Oh.
Hold on to your thought, though. I know exactly what you're thinking. Give us just a second and we'll get there. Let's flip it vertically. Let's reflect that thing over the x-axis, which means that all my outputs are now going to be opposite. But 0 stays the same, right? I didn't flip 0.
1, negative 1. 2, negative 4.
So down here, this lonely little pink guy is g of x. You did yours?
That was vertical.
Very good. There's a vertical reflection. And then let's do h of x in green, which means I'm going to take this point for input is 1, 1. I should have the same point at negative 1, 1. So there's that point. And instead of inputting positive 2, I'm going to input negative 2 and output 4. Instead of inputting positive 1, I input negative 1. Can you see how this is working?
You can't see where. Yeah, I just said
It's exactly the same.
you did both.
It's exactly the same function. And if I had any kind of steadiness, you would have seen that I went right over the top of that. Can you see it? Okay, so this brings up a new topic. It's also h of x. So in this case, h of x is equal to f of x. In other words, f of x is equal to f of negative x, meaning I get the same thing on both sides. Whether x is positive or negative, I'm outputting the same numbers. Are you understanding that? Whether x is positive or negative, my outputs are the same. We call this an even function. even function. So the rule here is whether the input is positive or negative, comma, the output is what? How would you finish this statement? Whether the input is is negative or positive, the output is the same. The output is the same. It doesn't matter if I'm putting in 2 or if I'm putting in -2. What's the output? 4, right? In this particular function, if I input 2, if I output input -2, I output 4. Both have the same y value. That's the definition of an even function. I'll give you a big clue as to why it's even. What's the degree here? 2. We're making pairs of those negatives, so they come out positive, right? So that's sometimes a rule. I wanted to have you write down a couple of things. I took pictures. Determining even and odd functions, okay? So this says some functions exhibit symmetry. I'll just read it to you. You don't have to write this down, but you got to listen. Got to listen. Marcus, lick your eyeballs. Like this. Okay. Some functions exhibit symmetry so that the reflections result in the original graph. The reflection resulted in the original graph. You saw that. We just graphed it. Another one like x squared would be absolute value. Think of it. It's the v, right? It's a v whether I'm looking at it like this or like this. It's the same picture, right? Because that's the case, we say that these types of graphs are symmetric about the y-axis. Think of, were y'all ever a little kid? That's an easy question. Were you ever a little kid? No, you weren't? Well, when I was a little kid, they would squirt us paint on our paper, and then we would fold our paper over and mash it really good, and we would open it up, and they would say it's a butterfly or something silly like that. But what we were doing was we were finding symmetry. Y'all must have missed that one day in school.
I mean, I wasn't a little kid, but I was definitely a young kid.
You were a young kid when you did that? Did y'all ever mash paint together and then unfold it?
I did it in Head Start.
I know I did it. If I did,
I did it in Head Start at Lamar.
In Head Start at Lamar. Okay, so in case you were absent that day, what they did was they pushed some paint together and then they folded a paper and then you open it and they should match on both sides. That's symmetry, okay? These functions, we say, are symmetric on the y-axis. They fold over that y-axis, and they're the same on both sides. That's called an even function, okay? But what if it's not? Then it's an odd function. Could it be neither?
Yeah.
It could be neither, okay? Think of your square root function. Your square root function is not symmetric on anything, right? It is not. But the cubed root or the cubic function, look at this one. Y'all see this picture right here? F of x equals x cubed. This is symmetric, but it's not symmetric on the y-axis. It's symmetric on the origin. No, because if I folded it on the x-axis, I'm not going to get the same thing. But if I fold it on this line y equals x, okay, a lot of times they'll say it's symmetric about the origin. Meaning if I flip it and flip it again, I should get the same thing. Imagine if we reflected it once over the y-axis and then again over the x-axis. Then I get the same thing. Okay, that's called an odd function. And your rule for an odd function, I don't think that we have a rule on this page. I'll write the rules on the next page. Right here. The rule for the odd function, it has to flip twice. It's negative f of negative x. Okay, so write these down. We've got to determine whether the function is even or odd. F of x equals negative f of negative x, that's even. So no matter what my x is, I get the same output. And then f of x equals negative f of negative x. That's going to be an odd. You've got to reflect it twice to get the symmetry. Did you close last night?
No.
No? You're looking like you've been closing a lot lately.
Technically, it wasn't late.
That's still late. I mean, I'm exhausted after school. And then you go to work. Power to you, man.
Where
Respect.
do you work?
Gray County.
Huh?
Gray County. Oh, wait. What?
Oh,
That?
that? Gotcha. I heard just Gray County.
I heard Gray
Huh?
County as well.
Mugshot? Gray County. Gray
It's like,
County.
there's so many
What?
places in here.
Yeah.
I work in Gray
I
County
was
too.
so lost.
All right, so
I'm feeling tired.
listen. Listen. There are a lot of functions that don't fit either one of these rules. Okay, so it doesn't have to be classified as even or as odd. It could be neither. Also, your exponent here is a great indicator of what it could be. All right, I will tell you that a polynomial that has an odd degree, so like 3 or 5 or 7, those guys are never going to be even. They're never going to be even. There's a very good chance that they're odd, but they don't have to be. It could be neither. So don't let that fool you, okay? If I have x to the second or x to the fourth or x to the sixth, those guys are never odd. A lot of times they're even, but don't just bet on it. Prove it. Do you understand what I'm saying? Okay, so here it says, determine whether the function is even or odd or neither. Well, I can tell you right now,
Dog.
it's not even because that's a power of 3, right? So this could be odd. We're going to prove it. If it's odd, here's what happens. F of x equals negative f of negative x, meaning I flip it over the x-axis and the y-axis, and then I see the same function. Did you follow that? That was the rule for odd. If it's odd, it flips twice. Once over the x-axis, that's the negative right here, and once over the y-axis, that's that negative right there. Have I lost you? Pick a number, Mason.
Up.
1. 1. Pick the number 1. Okay, so here's what we're going to do. We're going to test it. We're going to try f of 1 in this equation. Okay? 1 cubed plus 2 times 1. If my input's 1, what's my output? 1 plus 2. This is my function. X cubed plus 2x. I'm plugging a 1 into that place for x. Can you see? So 1 cubed plus 2 is 3.
Okay.
Okay? Now let's flip it. Let's plug in a negative 1. F of negative 1. This is to reflect it across the
Wait.
y-axis.
Why is there a negative 4? I mean, negative on the F.
I'm going to make the end result negative. I'm going to handle this negative part second. So right now I'm flipping across the y-axis, and then we're going to flip again and see if we get the same number.
It would be -1 cubed.
So negative 1 cubed plus 2 times negative 1. What is negative 1 cubed? Negative 1 minus 2. Negative 3. Okay, so right now they're not the same. But I need negative f of negative 1, which is to make this negative 3 positive, right?
So they are the same.
So they are the same. So since they are the same, what we can say here is f of 1 equals negative f of negative 1. So the function
It's odd.
is odd.
Is that the same with every odd number?
No. Just because the power is odd doesn't mean the function is odd. Because the power is odd means the function is not even. But it could be neither. So you got to check it. Okay? So I always pick 1. 1 is a really friendly number. It's a really easy number. You're going to plug in 1. You're going to plug in -1. If you get the exact same number at that point, they're even. Okay? Otherwise, you're going to plug in 1, -1, and then flip the -1 answer. If you get the same number then, it's odd.
I didn't know what you were doing.
No, I'm trying to help you.
Like throwing your hands at us.
I'm throwing your hands at you because I want you to get this.
I couldn't see.
Okay, here's a try it.
She was saying to pick a high number.
Here's a try it. Okay? Is this function even, odd, or neither?
All right. What is
Okay, so we know what? What do you know right now? You want me to blow it up?
It's even.
F of S equals S to the 4th plus 3S squared plus 7. We know it's not odd. There's a chance that it's even. It just doesn't have to be, so you've got to prove it. Okay? Now, how do we know if the function's even? What's the rule?
You gotta do -S.
F of S is equal to F of
Negative.
-S. What that says is no matter which one my input is, whether my input is positive or negative, my outputs are equal. Are you imagining the picture? Okay, that's what we're testing here. What number should we use? 1. So let's find F of 1. That's 1 to the 4th plus 3 times 1 squared plus 7. I got a 1 plus a 3 plus a 7. What's my number? 11. Yeah?
Yeah.
Okay, now F of -1. We're going to now plug in that negative. And we know when we raise that negative to an even power,
It's gonna be positive.
stays positive.
So it's gonna be
Stays positive. Yeah, that's the nature of the even, right?
1 plus
So
3.
1 plus 3 plus 7 is
It's even.
11. So since we got the same thing in both places, we got 11 equals 11. Now we know this function is even. Had we gotten different numbers, flip the second one. That would test if it was odd, right? If it's not odd or it's not even, it's neither. And that's a possibility. You're going to get a neither. Is this feeling better?
Yep.
Okay, so switch your X value, test the positive, test the negative, and then flip the negative, and that will tell you if it's odd. Any questions on that? Your homework is 5 of these. That's what this is. And you've got this due on Thursday, in addition to yesterday's, and tomorrow's a work day. Cool?